In section 6.2, talk about place value systems. So in section 6.1, we just talked about additive and subtractive systems. So remember that both the new Roman and Egyptian numerals use an additive property, but Roman also had that idea of a subtractive property. So now what we're going to kind of be moving away from that, and instead what we're going to be doing is stuff with essentially bases. So we have to first understand how bases work in our own Hindu Arabic numeration system. So if we have the number 4,672, we can rewrite this as 4,000 plus 600 plus 70 plus 2, which would be 4 times 1,000 plus 6 times 100 plus 7 times 10 plus 2. Well, each of these is a power of 10. So we really have 4 times 10 cubed plus 6 times 10 squared plus 7 times 10 to the first plus 2 times 10 to the 0. And I know you may be asking yourselves, why in the world would I write it that way? And I know it seems very odd to write it that way right now, but it does help using other number systems, so just bear with me. So if we were to write this using words just to connect our numerical to our English language, this would look like 4,000 672. In example 6.2.2, now we're going the other way. We have a number that's written in the expanded form for a Hindu Arabic numeral, and we're going to condense it. So first thing I'm going to do is I'm going to work backwards to what I did before. So 10 cubed is 1,000, so I have 2 times 1,000, plus 7 times 10 squared. 10 squared is 100, plus 6 times 10 to the first, so 6 times 10, plus 3 times 10 to the 0, or just 3 times 1. Anything to the 0 power is just a 1. So 2 times 1,000 would give us 2,000, 7 times 100, 700, 6 times 10, 60, and then we just get a 3. So our answer is 2,763. Now you don't have to show all this work when you're working these out. I'm just doing it because I want to make sure we understand how these values work. In the next example, we use the expanded forms to add numbers together. So our first step is putting these into an expanded form. So we have 8 times 10 plus 5, and then we have 5 times 10 plus 7. So I'm just going to line them up, each place value, and then we're going to add them together. 5 plus 7 gives us 12. 8 plus 5 gives us 13 times 10, because we're in the 10 place value, so both of these give us trouble. So first thing we're going to do is we're going to split up this 12 as 1 times 10 plus 2, and then we're going to split this up. This will be 10 times 10 plus 3 times 10. So notice here we end up grouping them. So the 2 is still on its own. 1 and 3 are both multiplied by 10, so we really have 4 times 10. And then here we still have 10 times 10. Or 1 times 100 would be the same thing. So our answer is going to be 142. Part 2 of section 6.2 is using the Babylonian number system. So the Babylonians used an additive feature similar to the Egyptians, but theirs was based on place value. So let's look at an example. So our main two numerals that we're going to be using are like this V shape. So I'm going to use this as a V or something that looks like that to represent 1. And then we have a sideways V to represent our tens. So those are the only two characters they had, and then they determine place value by using powers of 60. So then in these gaps are all going to be powers of 60. So this one is going to be 60 to the 0, 60 to the 1, and then this would be 60 squared. And then we're going to just convert the numbers to the Babylonian numerals. So this is just a V, so I have 1 times 60 squared plus 1, 2, 3, so 30, and then a 1 times 60 to the first plus 1, 2, 1, 2, 3, 4, 5, so 25 times 60 to the 0. So this would be 1 times 3600 plus 31 times 60 plus 25, because 60 to the 0 is 1, 60 to the first would just be itself 60, and then 60 squared would be 60 times 60. And when we add those together, we get 5,485. Now when we want to write a number as a Babylonian numeral, the process changes quite a bit. So here, what we're going to have to do is we're going to have to divide out as many 60s as we can. So we write 8503, and I'm going to divide out a 60. So I'm just going to show my calculator right here. So when we take out a 60, we're left with 141, and then a remainder. So I'm going to subtract off my quotient, and then multiply that by what I divided by so I can get my remainder. So my remainder was 43. So now we're going to take another 60 out of 141, because 141 is also divisible by 60. So this time we get 2. Again, we're going to take that off times 60. So our remainder here is 21. So now when we write this value, it's going to be 2 times 60 plus 21 times 60 plus 43 times 60. So we're going to go up and over this way. And this is always going to be the lowest place value at the top, and then we work our way down. So this is a 0, a 1, and a 2. So as we write it as a Babylonian numeral, now we're ready, and we need to leave a space between each power of 60, just like we saw up here. So 2 would be 2 of those. Then we're going to leave a space. Then we have to do 21. So that'd be 20. So 2 10s and a 1. And then we leave another space to do 43. So we have 4 10s now and 3 Bs. So just like we use hieroglyphics and expanded form to add numbers together, now what we're going to do is we're going to take our Babylonian numerals and we're going to add them together. But this time something bumps over when we make a 60, because again here we're using base 60. So it's a little bit different but similar to what we were doing before. So looking at our numbers, we're just going to start from this side and work our way over just like normal. So we have 1, 2, 3, 4, 5 ones. So we have 5 ones, and then we have 1, 2, 3, 4, 5, 6, 7 of these 10s. So remember 60, so 6 of those makes 1 over here. So now we already have 1 over here, and then we'll be left with 110 over here. So now we're going to add this together. So we have 4 other 1s, so that gives us a total of 5 of those. And then we have 1, 2, 3, 4, 5, 6. So again we have another 6. So that's going to bump over to here, because that's one more group of 60. So our final answer would be 1, and then we leave a space, and then 5 1s, and then we leave a space, and then we have 15. So a 10 and 5 1s.